Alhamdulillahi Rabbil Alameen Assalatu Wassalamu ala Rasulil Kareem. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll talk about physical properties of soil. The physical properties of soil are those properties that we can see or we can feel and which are relatively more permanent than chemical properties. So because these are mainly dependent on the soil formation processes and the parent material. So that's why these are more permanent and there are very less effects of anthropology and the human activities. In these we have texture, we have structure, we have particle and bulk density, porosity, air and water content, consistency, then color, and we have also the temperature. We'll discuss few of them here in the next slides. Soil texture, it refers to the relative proportion of three primary soil separates or soil uh, particle types, that is sand, silt, and clay. And the mainly the difference between these three type of soil separate is based on the size, the diameter of those particles. Uh, in general, we have three, but sometimes we divide the sand into two parts. The first, the coarse sand that range from 0.2 to 2 millimeter diameter, and above that are gravels. In fine sand, we have 0.02 to 0.02 millimeter diameter. Then we have silt, which is 0.002 to 0.02 millimeter diameter. And then we have clay particles, which are the finest particle in among these three, that have less than 0.002 millimeter. So it means less than this diameter, all the particles they are included in clay. So based on that, the proportion of these sand, silt, and clay, we can divide the soil into different classes, which has been mentioned here. So you will also learn in the practical class. But I will just briefly say that this is the percent clay, and then we have percent silt here, and then we have percent sand, and the total of these three kind of particle must be 100. So it means we have to calculate the particles sand, silt, and clay in percent, so that we can precisely judge that which one is the textual class. So by using this triangle, if we know the proportion or percentage of sand, silt, and clay, we can determine that what is the soil classification and what is the type of soil texture. So what is the significance of this soil texture? Texture is important because it will determine the ease of soil tilling. If we have a clay soil, then we of course we will have a difficulty to till, and if we have more sand, then it will be easier. So depending on the ratio of these three particles, we can determine that what is the the what is the status of the tilling, mean the ease of tilling. Then we have a soil aeration, because the soil aeration is also dependent on the soil particles. If we have fine particles, we have more pore space. If we have coarse particle, we will have less pore space. It means less aeration. Then we have a water intake rates, that uh, how fast water is absorbed to the soils. If we have a sandy soil, we can observe easily that there will be high intake, and if we have a clay soil, the intake will be lesser. I mean the rate of intake. Then the water storage in the soil. If we have a, a clay soil, so we have more space for the storage of water. So if we have sandy, we have a less space, and of course there will be more infiltration or more leaching, and the storage capacity will be less. Then soil fertility, as we have already discussed in many lectures, that the more or the most of the nutrients, they are attached or held on the clay particles. So it means the clay content in the soil that also determines that what is the nutrient status in the soil. A fine texture, just for an example, a fine textured clay soil is difficult to till, has poor aeration for good root growth, is difficult to wet and difficult to drain because they have micropores and the water movement is very less as compared to sandy soil. Can retain more nutrients and water as they have more pore space. Capillaries are more in clay soil. In leaching of water is very less, or the movement of water is very slow. So it means it can hold water, and of course, as I mentioned, a nutrient as well. So the second point has poor aeration for good root growth. So some raise question that the clay soil has more space. So then how the poor aeration? Uh, because the total porosity or pore space of the clay soil, so that is more, but the number of macropores, so that is lesser. So that is the reason that the for growth there are more macropores, and there is more aeration, means the exchange of uh, air with the uh, exchange of soil air with the atmosphere. Then we have soil structure. It is not like texture, mean the texture is the proportion, but the structure is arrangement of those soil particles. We have sand, we have silt, we have clay, and the arrangement of those particles is called as structure. The term structure relates to the clustering, grouping, or arrangement of primary soil particles into secondary particles, are units called pads or aggregates. Uh, it means that the soil is generally not in singular form. It means the each soil particle is not separate. So they are just grouped together to form a secondary particle. So that is called pads, or we also say aggregates. And the arrangement of those particles uh, can reveal that whether they are look like plate, whether they are block type, or they are granular. So based on that, we can uh, recommend, or we can give the recommendation about the utility of that soil. Other than these, we have also the structureless single grain mean soil, mean the structure has been disturbed by some way, maybe due to the sodium or other factors. And there is an other structureless form which is the massive form, mean they are not scattered, they are not dispersed, they are not singular grain, but they are just compacted to each other very hard. So that is also not a structure. So both these conditions, the single grain or the masses, they are structureless. So which are of course not healthy for crop production. So then we have a kind of prismatic, that is also a arrangement of soil particles or primary soil particles to form a group which look like the prism. The importance can be observed that the formation and the maintenance of stable aggregates is the essential feature of the soil tilth. Soil tilth, what is soil tilth? Soil with good physical condition are important to good yield. Mean the structure that is important for soil tilth. Soil tilth means the physical condition of the soil uh, which control the water and infiltration, rate of water infiltration, water holding capacity, heat transfer. Mean when there is no aeration, of course, then the heat transfer is different when we have a massive structure. So we have in some cases we have air between, in some cases that is a totally solid part. Aeration, of course, the porosity, the total pore space uh, in the soil, and then of course it affects the root development greatly uh, because the as I mentioned in the previous slides that these characteristics like porosity and aeration so that influence the root development. So it means soil structure has impact on the soil tilth. Soil tilth is just a term which is used in agronomy. You may have discussed in agronomy courses as well. But this soil tilth is important for these characteristics. Aggregated soil is generally the most desirable condition for plant growth for critical early stage of germination and seedling establishment. The continued existence of large pores in the soil depends on the stability of the aggregate. So this is again the soil structure. So we need aggregated soil for crop production, for better plant growth, especially the germination and the seedling establishment stages. So we don't need structureless, whether it's a mess or massive or it is a singular grain. So we don't need that. And secondly, we need stable aggregation because if the aggregates are not very stable, so at any stage of plant production, they can affect the plant. Particle density of soil refers to the ratio of total mass of the solid particles to their total volume excluding pore spaces. So this is important for agriculture point of view, of course, and the formula is total mass of solid divided by total volume of solid minus pore space because we have to exclude them if we want to calculate the particle density. Its units megagrams per cubic meter, grams per cubic centimeter or kilogram per uh, cubic meter. The range which is generally required uh, for this particle density in most mineral size varies between 2.6 to 2.3 megagram per cubic meter. However, the standard value used in calculation is 2.65 megagram per cubic meter. So if actual particle density is not known. So generally in most of the mineral size we use this value 2.65 uh, but in most of agricultural lands the particle density range between 2.6 to 2.7. uh, of course this is for the mineral size. Then we have bulk density. It is also the ratio of mass of the soil and the volume of the soil, but we use a term bulk volume mean the pore spaces they are also included in that. So we define as the mass of dry soil solids per unit bulk volume. It means the pore spaces they are not included. We have the similar unit here, that is megagram per cubic meter, gram per centimeter, cubic centimeter, and kilogram per cubic meter. Bulk volume means the volume of the soil particles plus pore space. Uh, in comparison with the particle density, we have a great significance for bulk density in agricultural lands. The bulk density of the soil is used for estimating the mass of the volume of the soil too large to weigh. Because we can determine the volume. For example, if we have a 1 hectare, we can determine the volume, that the area, the surface area, and then we have the depth, a certain depth, and we can calculate very easily the volume, but we cannot weigh them, weigh that soil. So to weigh that soil, if we know bulk density, we can calculate the mass of the soil, because we know we have the mass of the soil in bulk density formula. It is needed for converting water percentage by weight to content by volume. Of course, we can calculate on the other way, because generally the water percentage is calculated on weight basis. We take the soil, we saturate, and we calculate the water percentage. And if we know the bulk density, so we can also calculate based on the volume, so that we may know that this volume of soil need how much water. And of course, it will be used for irrigation augmentation. And the next importance or important point, that is, it is also used for calculating porosity when the particle density is known. If you know the particle density, and you know the bulk density, you can calculate the amount of pores or the porosity of the soil, or the pore spaces in the soil. It can indicate the compaction of a soil resulting from heavy tillage equipment on wet clay soil, because uh, if the soil is compacted, of course it will reduce the pore spaces. And if you know the bulk density before the tillage with equipment, heavy equipment, and then after the tillage you can calculate the bulk density, and then uh, uh, you can report that whether there was a compaction and how much compaction was there. So this is important, the bulk density is important to calculate the compaction. And resistance to plant growth, plant root growth, can be assessed through bulk density, because it basically tells you about uh, the pores in the soil, so which are of course uh, which is of course a good indicator to tell about the resistance which will plant face or plant root face to grow into that soil. The pore space of a soil is the portion of soil bulk volume occupied by soil pores, and the soil pores mean which is held with water or air. And actually the pore space uh, is the porosity of any soil. On the other way, we can also mention that it consists of that portion of the soil which is not occupied by solids, because we have soil solids in the soil. Whenever you get one piece of a soil, one clod of a soil, you will have soil solids, and then you will also have some air, and you will have also some water content in that clod. So basically, so that the space occupied by water or by air, so that is the porosity. We have also some micropores in the soil, which we refer to the capillaries like, and we have also macropores. And in most of the cases, the micropores, so they can hold the water uh, more as compared to macropores. And macropores, so they increase the rate of the flow of water in the soil. So both are important. We also need micropores and we also need macropores. But when we talk about porosity, so that is the total pore space. The micropores are generally filled with water in a moist soil, and there is a slow movement of air and water into or out of the soil. So because they can hold more water, so that will resist the movement of air. But on the other hand, the macropores, uh, they allow the swift movement of water and air. Thus, the movement of water and air through a sandy soil is rapid due to dominance of macropores, and even though total porosity is relatively lower. In sandy soils, we have low pores, total pore space, and we have macropores. Uh, and macropores mean there is a swift movement of water, and of course air is also very important, but on the other hand they are not able to hold the water. There will be fast movement of water, and the water will go out of the root zone. Clay soils, particularly those without good structure, allow relatively slow air and water movement despite having large total pore space. So clay soil, so they have total more space, pore space, but uh, they have relatively slower air and water movement, and mentioned earlier. Uh, so it means we need macropores as well for the air circulation, and we also need and of course the macropores are also important for ease of root growth and ease of tilling, and the micropores, they are important for water holding. Improvement in structure can promote aeration. In case of clay soil, if we increase the aggregation in the soil, then of course there will be more pore spaces, mean the more macropores, and that is actually called as the improvement in the structure. So therefore the pore size distribution is more important rather than the volume of total pore space. So this is important. Okay, pore, macropores and the micro both are important. We have to consider both. Total pore space doesn't matter, because we know that clay soil have more porosity, more pore space, and the sandy soil have a less pore space. But the macropores, they are more in sandy soil, and micropores, they are in clay soil. So this is not important, but the important is that the distribution of macro and micropores in the soil. Soil aeration is the process by which air in the soil is replaced by air from the atmosphere. So that is basically the gaseous exchange. We know that we have air, atmospheric air, and we have some air in the soil. So, but the both have some variation in the composition. So, for healthy air, so that soil the air must be exchanged with the atmospheric air. The rate of aeration depends mainly on the volume and the continuity of air-filled pores within the soil. So if we have a more pores with air, then of course there will be more rapid exchange of gases. And here again the soil porosity is very important, and especially the macropores, because the micropores are generally filled with water and macropores have air to exchange with the atmospheric air. Just for estimation, we have this comparison of soil air and atmospheric air. So there are three main gases. Uh, we can observe here that atmospheric air has more nitrogen as compared to soil air. Of course, that nitrogen is utilized maybe. Then we have oxygen that is more in the atmospheric air, and in the soil air that is less, because the oxygen is utilized in the respiratory system and the respiration in the plant and the microbes, of course. And then we have also uh, carbon dioxide, which is much higher in the soil air as compared to atmospheric air. So it means we need continuous exchange to have a balanced composition of especially these three gases which are involved in plant growth and of course for the respiratory system, respiration of plants. And in for this exchange, we must need a balanced pores, or we need macro pores, especially for the gases exchange. Uh, Respiration, as I mentioned, that is the significance of soil air aeration, which is needed for microbes and for the uh, plants. Uh, Rice is the only plant which can take oxygen or exchange the gas through the stem, so that's why that can grow in the flooded condition. But all other crops need oxygen for root growth, and for which aeration is very important. The rate at which oxygen exchanges with atmospheric oxygen is important because we need a continuous amount of oxygen for root root growth and plant growth, and if the rate of that atmospheric oxygen and soil oxygen exchange rate that is not sufficient to provide oxygen to the plant root, so it will affect the plant growth. So this is called as the ODR, oxygen diffusion rate. Again, it is dependent on the macropores. If we have a less aeration, so then there will be some anaerobic microbes in the soil because the aerobic microbes needs oxygen. But if we deplete oxygen in the soil, so then there are microbes which can also work under anaerobic conditions, but they are harmful in such a way that they also produce very harmful gases like nitrous oxide, methane, and hydrogen sulfide.